Algebra 2, Chapter 7, Section 5, Solving Radical Equations. In this section, we're just going to learn how to solve radical equations. Okay, let's define. A radical equation is an equation that has a variable in the radicand or has a variable with a rational exponent. So, great example. That's a radical equation. That's a radical equation. This one is not a radical equation because the variable is not in a radicand or does not have a rational exponent. To solve radical equations, isolate the radical on one side of the equation, then raise both sides of the equation to the same power. Okay? Easiest way to do this is let's get some examples. So, example, solve 2 plus the square root of 3x minus 2 equals 6. Step 1, isolate the variable. So we're going to subtract 2 to each side. We're going to get the square root of 3x minus 2 equals 4. Now, let's square each side to get rid of the radical. So I'm going to get 3x minus 2 equals 4 squared, which is 16. Add 2 to each side. So I get 3x equals 16 plus 2 is 18. Divide each side by 3. X is going to equal 6. Okay, now we've got to check. Okay, now we've got to check. So we'll just plug 6 back in. And you can see to the left right here, we're going to check the work. The reason we got to check these is because sometimes we're going to get extraneous solutions. So you can see on the check it's going to work out just fine. All right, next example. Square root of 5x plus 1 minus 6 equals 0. So step 1, add 6 to each side. So I'm going to get the square root of 5x plus 1 equals 6. Again, all I did was added 6 to each side. Now I'm going to square each side. It's going to take away the radical. So it's going to be 5x plus 1 equals 6 squared is 36, so now we're going to subtract 1 to each side. So I'm going to get 5x equals 35. Now divide 5, so I get x equals 7. When you double check it, it's going to work, so x equals 7. All right, plugging along. Now you can solve an equation in the form of x to the n over m power equals k by raising each side of the equation to the power of n over m, the reciprocal of mn, okay? If n is even, then x times n over m is the absolute value of x. If n is odd, then it is x equals x. So again, if our n value is even, it's going to be the absolute value. So let's check it out. So solving radical equations with rational exponents. Okay, so I have 2 times x minus 2 to the 2/3 power equals 50. Step 1, isolate the variable. Divide each side by 2. So I get x minus 2 to the 2/3 power equals 25. Now, take both of these and let's just flip it to the reciprocal and put it to the 3/2 power. All right, since my n value is even, I'm going to say the absolute value of x minus 2 equals 25 to the 3/2 power. So the absolute value of x minus 2 equals, well, the square root of 25 is 5, and 5 cubed is 125. So it's going to be 125. So x minus 2 equals plus or minus 125. So x is either going to equal 123 or 127 or negative 123. So let's double check. We got to check both solutions. So we're going to go do it. 2 times x minus 2 to the 2/3 power equals 50. 2 to the x minus 2 power to the 2/3 power equals 50. So let's do x equals 27. So 127 minus 2 to the 2/3 power equals 50. 2 times negative 123 minus 2 to the 2/3 power equals 50. Okay, it's going to be 2 times 125 squared cube rooted equals 50. 2 times negative 125 squared cube root. So 2, the cube root of 125 is 5, so it would be 2 times 5 squared equals 50. So 2 times 25 equals 50. So 50 equals 50. So 127 works. The cube root of negative 25 is negative 5, so 2 times negative 5 squared equals 50. So 2 times 25 equals 50. So 50 equals 50. So both solutions work. So x equals 127 or negative 123. All right. Hopefully that makes sense. Moving on. Solve x 2 times x plus 3 to the 3/2 power equals 54. Okay, since my n value is odd, I'm only going to have one solution. So 2 times x plus 3 to the 3/2 power equals 54. Divide each side by 2, so I get x plus 3 to the 3/2 power equals 27. So let's take each side to the 3/2 power. Let's do the reciprocal, so it'd be 2/3 power. Okay, so that's going to just be x plus 3. Since it's odd, I don't have absolute value signs. 27 to the 2/3 power. Well, the cube root of 27 is 3, and 3 squared is 9. So x plus 3 equals 9. So subtract 3 to each side. X equals 6. So the answer is C. And you can double check your work, and it's going to work. All right, so let's look at a real world solution here. A company manufactures solar cells that produce 0.02 watts of power per square centimeter of the surface area. A circular solar cell needs to produce at least 10 watts. So what's the minimum radius? All right, so we know it's going to produce 0.02 watts per square centimeter. We know it's circular, so we know the area of a circle is pi r squared. And we know it needs to be at least 10. So we got to solve for r. So easy enough. All we have to do is isolate r. So divide everything by 0.02 and pi. So r squared is going to be greater than or equal to 10 over 0.02 pi. So r squared is going to be greater than or equal to, now you can just plug that in your calculator. That's the easiest way to go about doing this. Okay, and when you do it, you're going to get basically 500 over pi. So r is going to be greater than or equal the square root of 500 over pi. So r, once you plug in your calculator, is going to be 12.62 centimeters. So the radius, the minimum radius, is 12.62. Okay. A company manufactures solar cells that produce 0.2 watts of power per square centimeter, just like the example we just did. A circular solar cell needs to produce at least 20 watts. So what is the minimum value? So again, it'd be 0.02 times pi r squared is greater than or equal to 20. Okay, if you wanted to use common sense, all right, we can figure it out. So let's see. Get your calculator. I have a handy dandy calculator right here. That may need to be reset. Okay, I'm going to take 20. Okay. And I'm going to divide it by 0.02 divided by pi. Okay, now I'm going to square root that, so I got r squared is greater than or equal to 318.3. 318.3. So I'm going to square root that. So we get 17.84. So r is greater than or equal to 17.84 centimeters. Okay, easy enough. Moving on. So now you've got to sometimes check for extraneous solutions. You may get it. So in this example, you had the square root of x minus 3 plus 5 equals x. Well, so now look, you have to work. You get the variable by itself. You square each side. So you get the square root of x minus 3 squared equals x minus 5 squared. You distribute and simplify. So you get x minus 3 equals x squared minus 10x plus 25. Get everything on one side, combine like terms, set it equal to 0. You get x squared minus 11x plus 28. Now you factor. You get x minus 4 and x minus 7. So you get x equals 4 and x equals 7. And then you plug it back in the equation. And you notice the 4 does not work, but the 7 does. So the only solution is 7. So you've always got to check for extraneous solutions. So here we go. I got the square root of 5x minus 1 plus 3 equals x. So subtract 3 to each side. So I got the square root of x minus 5, 5x minus 1 equals x minus 3. I'm going to square each side. So I'm going to get 5x minus 1 equals x squared minus 6x plus 9. Get everything to one side of the equation, set it equal to 0. So I'm going to get x squared minus 11x plus 10 equals 0. Okay, I can x factor this. Okay, my a times c value is 10. My b value is negative 11. Two numbers that have a product of 10 and a sum of 11, negative 10, negative 1. So I can rewrite this as x minus 10 times x minus 1. So x equals 10 or 1. So let's plug it back in and see what we get. So when x equals 1, the first one, we're saying the square root of 5 times 1 minus 1 plus 3 must equal 1. So 5 times 1 is 5, minus 1 is 4. So the square root of 4 plus 3 equals 1. So 5 does not equal 1. So 1 does not work. So let's try 10. So I got the square root of 5 times 10 minus 1 plus 3 equals 10. So that's going to be the square root of 49 plus 3 equals 10. So that's going to be 7 plus 3 equals 10. So 10 equals 10. So the only answer for that example is 10. So the answer for that one would just be B. Okay, next page, next example. Solving equations with two radical exponents. We'll finish this in the next lecture.